Hello everyone, how are you? Now we are going to do a quick review of chapter 1, routing concepts. So first we will discuss about what is routing. Routing is a process of finding the best route to forward the traffic to the destination. So in a network, which device is responsible for doing routing? Router, right? So we know what is the use of the router, what are the functions provided by the router, what is routing process, everything we know. And the router will maintain the routing table. In the routing table, all the routing informations are stored. We all know about these concepts. Go to the second slide. Now we will discuss about the different types of memories available in the router. What are the different types of memories available in the router? You know that RAM, ROM, NVRAM and flash. There are 4 different types of memories available in the RAM. So that is very important, that 4 different types of memories available, and we know what are the functions of each memory. Gateway. Why gateway is important for a network? Why gateway is important for an end device? For example, if 2 end devices connected in the same network want to communicate, no need of the gateway. If 2 devices are connected in different networks, for example, sender is connected in a network, the receiver is connected in the remote network. In this situation, we need a gateway for communication. The sender will communicate with the gateway will communicate with the next hop, the next hop will communicate with the destination. The best practice is, if you develop any network, you have to document that network. So how to document that network? So we are look at this topology. So this is a topology. This is a network we simulated or created. So once we complete it, we have to document it. That means in the network documentation, you should have the fields. What are the fields you should have? Device name, interface, IP address, subnet mask, default gateway. Look at here. The device names are available in the documentation. This documentation is called as the addressing table. In the addressing table, we will mention the name of the device, router. How many interfaces are available in the router? F00, S00. Yes. What is the IP address of F00? What is the IP address of S00? It is available here. And what is the subnet mask of that? That is available. So everything is available. If you see the end devices, PC1 and PC2, interface device information is not available for, not applicable for that. You have to enter its IP address, you have to enter the subnet mask, and you have to enter the default gateway. For PC1, the default gateway is router 1 F00. So router 1 F00 is 192.168.1.1. Same way you have to find out the default gateway for PC2. So right, we know all these things. Now IP address. IP address is very important for each host or each end device, each device in the network. So IP address can be assigned in 2 ways. One is static method, another one is the dynamic method. Static method means the administrator will configure the IP address manually. Dynamic method means we will use the DHCP server, or we will use the DHCP protocol to configure the IP address automatically to the devices. Console access. The console, if you want to access the IOS, if you want to do any changes in the devices, you have to access the IOS. To access the IOS, there are different methods are there. Console access method is there. Remote access methods like Telnet, SSH are available. So if you are going to use the console access method, we need a special cable that is called console cable. If you see the console cable, it is flat in size, and the 2 ends are terminated with different connectors. In one end, the RS232 connector is used. In the other end, RJ45 connector is used. RJ245 interface is connected with the end device, and then RS232 is connected with the end device, and RJ45 connector is connected in the console port of the router or switch. And in real time, if you want to configure or access the IOS, you require a terminal emulation program. TerraTerm, Putty, HyperTerminal, these are all the examples for the terminal emulation program. In our lab, we are using TerraTerm and Putty. Next, if you want to configure the switch remotely, definitely you require you have to configure the SVI. So a switch requires an IP address to be configured on a virtual interface. So this is called a switch virtual interface. You have to configure the IP address for the default VLAN. You know it is the default VLAN. Default VLAN is the VLAN 1. you have to configure the IP address for VLAN 1. Once you configure the IP address for VLAN 1, you can remotely manage the switch or remotely configure the switch through telnet or SSH. So how to do that? You have to just first get into the interface VLAN 1. So interface VLAN 1, then you have to use the command IP address, then followed by you have to type the IP address and subnet mask of that switch. Then you have to activate this by using the command noshed. If you see a switch, there are two important things. One is you have to configure the IP address. The second thing is you have to configure the default gateway. In this diagram, the switch 1 is connected with router 1. The interface G00 in the router 1 is the default gateway for switch 1. So you have to find out the IP address of the interface G00, router 1 G00, that is 192.168.10.1. So you have to configure this address as a default gateway address in the switch. To do that, the command is IP default gateway 192.168.10.1. Next thing is basic router setting. In router, if you see the IOS, we have user X mode, privilege X mode, global configuration mode, specific configuration mode, line mode, and then interface mode. Now we have to protect this mode by using the password. To secure this mode by using the password, first we will see how to secure the user X mode. To secure the user X mode, we have to use the command line console 0, and then the given password is Cisco. So password Cisco. You have to activate this password by using the command login. So like that, you can configure the password for the virtual terminal lines, that is the remote access. For that, you have to use the command line VDY 0 to 15, and then password Cisco, and then to activate the password, you have to give the login command. And in there are 15 virtual terminal lines are there starting from 0. 16 virtual terminal lines are there starting from 0 to 15. Right. Now, when we save, configure any password, the passwords are stored in the running configuration file. The passwords are stored as a plain text. Storing a password in the form of plain text is not advisable. We have to encrypt the password and we have to store it in the form of ciphertext. To encrypt each and every password stored in the running configuration file, you have to use the command service password encryption. The command service password encryption encrypts all the passwords stored in the running configuration file. Like that, you can warn the unauthorized users when they access the switch or the router through the banner command. To configure the banner command, you have to use the command banner motd, and you have to type the message within the delimiter. The delimiter means you have to start and end the message using a special symbol. The same symbol should be used at the starting and the ending. You can use hash or dollar, any symbol you can use. Right. Once you do the configuration, if you want to save the configuration permanently, you have to use the copy run start command, or you can use write command. This command will work only in the privilege X mode. If you want to use the command in global configuration mode, you have to add a do in front of this command. Then how to configure the IP address for the interface. This we all know that. For that, you have to go to that interface first. The interface name is G00. Then you have to configure the IP address by using the command IP address followed by the given IP address and subnet mask. You have to activate the IP address by using the noshed command. Next thing, loopback interface. Loopback interface is used in router for testing and management purpose. Loopback interface is a logical interface. It is not assigned to any physical port. It is a software interface. It is always in the up state, enable state. No need to use the noshed command. Now we will see how to configure the loopback interface. For that, you have to use the command interface loopback 0. Then you have to type the IP address provided. The provided IP address is 10.0.0.1, and then the subnet mask is 255.255.0. And no need to use the noshed command because it is always on. It is in the update state by default. So the loopback interfaces are used in the OSPF routing protocol. In the old version of OSPF routing protocol, in the latest version of OSPF routing protocol, we are not using the loopback interface. And if you want to verify the commands or the IP address after configuration, you can use the show command. For example, I want to see what are the interfaces available in router 1 and what is the status of that, what is the IP address configured for that. For that, you have to use the command show IP interface brief. So this command displays about the different types of interfaces available, what are the IP address configured, what is the status of that, whether it is enabled or disabled, and then the IP address is configured manually or automatically. All this information you can see. Like that, if you want to see the routing table of the router, you have to use the command show IP router. If you want to see the details, configuration of a particular interface, you have to use the command show run and then interface G00. This will provide only the information about the specific interface. Now how the router will forward the traffic to the next hop. When a router receives a message from the source, it will see who is the source, who is the receiver, and then it will find out the best path, and then it will forward the message to the next hop. So router 1 will forward the packet to router 2. So router 2, after receiving that, it will check who is the sender, who is the receiver, and then it will check the best path. Then it will forward it to the next hop. The next hop is router 3. The router 3 will forward it to the PC2. In this way, the router will work. And then what is the duty of the routers? When a router receives the packet, after receiving the packet, it will check who is sending this packet, to whom it is sending this packet. After receiving that, it will decapsulate, it will take the original message, it will check who is the sender, who is the receiver, and then it will check the best path. Again, it will encapsulate the packet, and then it will forward to the next hop. So this way the routers will function. And then when a router receives the packet, the router has to find out the best route. First, after receiving the packet, the router will search the routing table the router will search the routing table. A routing table search the result in one of the 3 path determination. First, the router will check that whether the destination is connected directly with the router or not. If it is directly connected, immediately it will forward the packet. If it is not directly connected, then it will check whether the destination is connected with the remote network. If it is connected with the remote network, it will forward to the next hop. If it is not connected with the remote network, then it will check for the gateway of last resort, that is whether any default route is configured or not. If any default route is configured, then it will forward it to the default route. If not, it will discard the packet. Then best path, the router will select the best path based on the metric or the administrative distance. The metric is a value which is used to select the best path. Based on the lowest metric value, the path will be selected. Different routing protocols will use different metric. RIP routing protocol will use hop count. OSPF will use the cost-based cumulative bandwidth from source to destination. EIGRP will use bandwidth, delay, load, and reliability. Load balancing, you know about load balancing. Administrative distance. Administrative distance, different root source will maintain the different administrative distance. Say for example, connected route will maintain the administrative 0, static route 1, OSPF 110, and then IGRP 100, ISIS 115, RIP 120. So administrative distance is used to determine the route to install on the routing table. The administrative distance represents the trustworthiness of the route. The lowest administrative distance, the more trustworthy. And then directly connected routes. So what is this route routing table? So we'll see what are the information available in the routing table. So this is the routing table. If you see the routing table, the what is the root source code is available, and then the destination address, and then the next is the administrative distance, and the next one is the metric value. Then this is the next hop address, then this is timestamp, and this is the exit interface address. If you see, there are different types of root source codes are there. L represents the local route, D directly connected route, S static route, T represents the dynamic route through EIGRP, O represents the dynamic route through OSPF routing protocol. And here is the benefits of the static route. What are the advantages of static route, and main types of static route. So how to configure the static route and then default static route. To configure the static route, you have to use the IP route, and then the destination network address, and you have to use the mask, command mask, and exit interface. If you are going to configure the default static route, you have to use the command IP route 0000000, and then you have to use the exit interface. And if you see, the static route is represented by using the root source code S. The default static routes are used by represented by using the S star. Dynamic routing protocol. We have different types of dynamic routing protocol. Say for example, EIGRP, OSPF, ISIS, RIP. We will discuss in detail about this dynamic routing protocol and static routing protocol in chapter 2 and chapter 3. In chapter 2, we will discuss about static routing protocol. In chapter 3, we will discuss about dynamic routing protocol.